Hi, this is Audrey from MacroSheds, and I'm really interested in understanding how do impacts of experimental chemical additions compare across Appalachian watersheds. And so I am a PhD student right now, and I currently work at Harvard Brook, and so I know of one chemical addition where they added wollastonite to one of the watersheds at Harvard Brook. And I was just reading this paper by Rosie et al., reminding me of some of the impacts of that experimentation. And so I wanted to look at this data that they looked at, which was nitrate export in addition to calcium and pH changes as a result of the wollastonite addition on the MacroSheds portal. And so you'll notice as soon as you navigate to MacroSheds, the default is looking at Harvard Brook experimental forest sulfate, and you can see that over time, sulfate in the watershed has decreased in response to recovery from acid rain. And so I'm interested in looking at the comparison of watershed 6 to watershed 1, watershed 6 being the reference site, watershed 1 being the experimentally manipulated watershed. And I'm interested in looking at pH, calcium, and nitrates. And so we're going to look at concentration, and let's do a yearly aggregation. And you can see that after the addition, which happened in 1999, initially pH increased a ton and then was steadily higher than it was in the reference up until about the end here. Similarly, if we look at calcium, you see that after the addition, you had a significant elevated calcium in the streams, possibly in direct response to the wollastonite addition. And finally, if we look at nitrate export, we see that after the addition, almost a decade later, we have enhanced nitrate in the streams, particularly in watershed 1. I also know of 2 sites that have added ammonium sulfite fertilizer to evaluate the response of acid rain to the watersheds, whereas at Harvard Brook they added wollastonite to reverse the effects of acid rain. And I'm not as familiar with those 2 sites, and so I'm going to rely on the MacroSheds map here to help me determine where those experiments took place and what the reference watersheds might be. So if I navigate to Bear Brook in Maine, we see that there are 2 watersheds. The first is East Branch, which might be our reference. And the second, we notice that when we click on the watershed gauge, it has a flag here. And if we navigate to the flag, we see that West Branch is indeed an experimental watershed and had a chemical addition of ammonium sulfate that was added. And so we're going to add that to our cart, and now we have 2 different watersheds in our cart, where East Branch is control and West Branch is the experimental. And to be the same as Harvard Brook, I put the control in blue and our experimental in pink. So let's plot. And same thing, we're looking at pH. You can see that our control plots here East Branch has a higher pH than West Branch. And then in contrast, West Branch has elevated calcium in the stream and also elevated nitrate, which is interesting. And so I'm interested in also comparing the other watershed that added the same chemicals to the watershed and see what those responses were. And that was Inferno, which is in West Virginia. So if we navigate to West Virginia here, we notice that Furneaux has a lot more watersheds. And so let's just click on watershed 4. Okay, this appears to be, I'm going to remove the cart's main. So this appears to be a reference watershed. It doesn't have a flag, and so I'm going to add it to our cart. And then I'm looking for the other chemical addition. So this has a flag, but we look here and we notice that there's no chemical addition. Instead, it was a timber harvest, so it wasn't watershed 5. let's check watershed 3. And this one has timber harvest as well, but in addition, a chemical addition where you have acidification by ammonium sulfite fertilizer applied 3 times per year in 1989, which is the watershed we were looking for, and so we'll add it to our cart. And then let's plot. So here we have watershed 3, which is our experimental, and watershed 4, which is control. And so I'm just going to reverse those colors just so that it's consistent with our previous visualizations. Okay, so now we have watershed 4 on top in blue, which is our reference site, and watershed 3 is our experimental. And you can see again a change in pH over time, elevated calcium, and elevated nitrate, which was the exact same as the other plots. And so now I'm interested in comparing Furneaux's experimental plots to Bear Brook and Hubbard Brook's to compare those experiments to one another. So I'll add in Bear Brook, Furneaux, Hubbard Brook. And I remember that in Bear Brook, West Branch was our experimental site. In Furneaux, watershed 3 was our experimental site. And at Hubbard Brook, watershed 1 was our experimental site. And we're still comparing pH, calcium, and nitrates, but this time I'm going to look at volume-weighted concentration because they may have different discharges. And so here, if we look at, let's look at concentration, just so that we can see pH first. So here, if we look at pH, you can see that both the Furneaux and Bear Brook sites have a marked decrease in pH, whereas at Hubbard Brook you see more of a recovery from pH because it was a different experiment. Similarly, calcium is elevated in both of the sites where you had a fertilizer addition. However, in watershed 1 at Hubbard Brook, you could see elevated calcium, but for a very different reason, not because it became more acidic, but instead because we added wollastonite, which contains a lot of calcium. And in addition, we see that West Branch and watershed 3 in Furneaux have elevated nitrate, and you can't really see some of this nitrate export at Hubbard Brook on this particular scale. And if we look at volume-weighted concentration, which gives you a better comparison among sites, you see that of all the sites, it seems that both Furneaux and the site at Furneaux, watershed 3, and West Branch at Bear Brook had a similar amount of calcium in concentrations in the stream, whereas in nitrate you could see that Furneaux had significantly more nitrate export than Bear Brook did, where Hubbard Brook is the least of these throughout the whole process. It would be interesting if we were to do a proper cross-site comparison to look at what different attributes might have contributed to these different trends, particularly in nitrate, and that could be due to vegetation cover or soil type, which might be different between the two sites. And we could even look at that by looking at land cover or perhaps even their underlying geology for each of the sites. Thank you so much for watching this brief demo, and I hope you stay to explore the MacroSheds portal. Thanks so much.